Hi, my name is Bahadur Ahmedov. Welcome to the course of Probability and Statistics. From this lecture, we're going to talk about the random variables. So actually, if you look around us, there are many random processes that are going on. For example, the number of the cups you drink per day is a random variable, or the amount of the time you spend in the social networking is a random variable, or amount of the time you watch the YouTube videos is a random variable. From the business perspective, for example, the amount of the customers which are coming to the store is a random variable, or amount of the cars which are crossing the cross section per minute, for example, is also a random variable. So understanding the random variables and use this understanding and analysis to make a profit, for example, or to understand something much more better is very important for us. And the probability as a science and as a subject is going to help us to understand the random variables much more better. From this lecture, we're going to learn about the random variables from a structural point of view. So we are going to talk about the types of the random variables. For example, there are two types of the random variables: the discrete random variables and the continuous random variables. And also we're going to talk about the distribution of the random variables. So let us define the random variable itself. A random variable is obtained by assigning a numerical value to the outcome of a particular experiment. The experiment, when we're talking about the theoretical experiment, might be, for example, the number when you roll a die. So you've got a die with the 6 sides, 1, 2, 3, 4, 5, and 6, and so on. You roll this, and every time when you obtain the result is going to be so every time when you roll this, you're going to get the result, and this result is a random. And we are going to talk about the discrete and the continuous random variables. So a random variable which represents a numerical value associated with an outcome of a probability distribution. In a discrete case, this random variable should be countable. So the example of the discrete random variables might be, for example, the result after rolling a die is a discrete random variable, or for example, the number of coffee cups you drink per day, cups per day, is the random variable, or the number of the customers which are coming to your store, for example, is a random variable. So or the number of the students who are attending the lectures, the online lectures even, is a random variable, or the number of the students who are watching every video is also the random variable. And all of them are the examples of the discrete random variables because you can count them, right? So for example, you can count the number of the cups you drink, you can count the number of the students who are watching the videos, and so on. And there is another type of the random variables which is called the continuous one. We usually get the result from the experiment, and we usually measure this. We don't count this. For example, the amount of the time you spend for watching the lectures in probability and statistics, for example, is going to be a random variable. So sometimes you might watch 4 minutes, sometimes 3 minutes, sometimes like a couple of hours, right? And every time this might be a different number. Every time this is a random variable, and you usually measure this. You don't count this. So another example of the continuous random variable might be the height of the students. You are going through the students in a class, for example, and you measure the height of the students, and every time it's going to be a random variable, and usually it is a continuous random variable because you are going to measure the height. You don't count the height. So hopefully you understand the differences between the discrete random variables and the continuous random variables. So depending on whether a random variable is a discrete or continuous, it is going to have different functions to represent them. So first of all, we're going to talk about the discrete random variables and its distributions. And before we do this, I would like to give you a couple of questions to identify which of the variables is discrete and which of them are continuous. For example, the distance your car travels on a tank of gas. So for example, you fill the tank of your car, and you drive this. So every time, depending on your driving style, for example, or the place where you're driving, this you may drive different amount of the distance for the same for one full tank of gas. For example, sometimes you might draw 400 kilometers, sometimes you might draw 200 kilometers. So this is the random variable, and actually this is the continuous random variable because you are going to measure this. You cannot count the distance, right? You usually measure the distance. And another example, the number of the students in a statistical class. So usually you can count usually the number of the students who are attending the class as a random variable. You don't know how many students are coming to the class every time. This might be a different number of the students. And this is the example of the random variable, which is discrete, right? Because you can count the number of the students who are coming to the class. For example, maybe 50, maybe 55, or maybe 25, right? So every time you can count them. So this is an example of the discrete random variable. So we are interested to know the distribution of the random variables, and the probability mass function is the function which is going to represent the distribution of the discrete random variables. Basically, what we are going to do is we would like to build an experiment, and we would like to find all the outcomes and the probabilities of all those outcomes put in one table is called the probability mass function. For example, so here are a couple of properties. So this is an example of probability mass function. But we can bring another example. So for example, so let's roll a die. Roll a die. So this is our experiment, and what kind of outcomes we might have. So the possible outcomes. You are going to have the outcomes in terms of the numbers, for example, right? So 1, 2, 3, 4, 5, 6. So by just finding the probabilities for every single outcome and putting them in one table is a process of creation of the probability mass function. So the table where I'm going to put the outcomes in one row and their probabilities in another row is going to be called as the probability mass function. So here I'm going to write down the probabilities if it is a fair die. So if it is a fair die, it means that the chances of getting any side are equal. The probabilities of getting 1, 2, 3, or 5 or 6 are equal. It's going to be equal to the 1 over 6. It's going to be 1 over 6, 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 and 1 over 6. So this is called the probability mass function. So one more time, the probability mass function, it is when you are going to find all the outcomes of your experiment and find their probabilities and put them together in one table. So it should fulfill a couple of properties. So the first property should be every probability, as it was written in the axiom of the probability, should be always positive and between 0 and 1, basically. So probability should be always positive. And the second property, which is the most important property, is that the sum of all the probabilities in your table, so sum of all the values of your probability mass function, should be equal to the 1. So here, for example, you have 6 of the 1 over 6, and if you just sum them, you're going to get 1. Or here, for example, if you just sum all the values for the probabilities, you're also getting 1. So this is the fundamental property of the probability mass function. The sum should be equal to the 1 always. If the sum is not equal to the 1, it means that your table is wrong. So let's do a couple of examples. So let's say I've got a spinner like this. Okay, so 1/4 part of the spinner is denoted as 1. 3/4 part of the spinner is denoted as 2. So whenever you roll the spinner, so the result which you're getting, 1 or 2, is going to be a random variable. So our random variable x is going to take 2 possible outcomes, either 1, either 2, right? And it's a random variable. So, and the probability of getting 1 or 2 actually is proportional to the area of the 1 and 2. Right? Because you spin the spinner and the probability that you're going to get 1 is going to be equal to the 1 over 4, and probability of getting 2 is equal to the 3 over 4, because the area which corresponds to the 2 is 3/4 of the area of the whole spinner. So this is the probability mass function for this random variable. In this case, the random variable is going to be simply output of the result of rotating the spinner. So we can make this experiment a little bit difficult. So in order to understand the probability mass function more deeper. So the probability of landing 1, now I know that I've got a spinner, I'm going to rotate this, probability of getting 1 is 1 over 4 or 0.25, probability of getting 2 is 3 over 4 or 0.75. So I'm going to rotate the spinner twice, 2 times. So now I would like to construct the probability distribution function for the sum of the spinner. So our random variable x is going to be the sum of rotating the spinner twice. So what kind of values for the sum you might take? In order to do this, I would like to write down all possible outcomes of the spinner. For example, you might get 1 in the first trial and 1 in the second trial. So whenever I say the trial means like you rotate it once and you rotate this twice. Okay, so 1 and 1, or it is possible that you may obtain 1 and 2, or it is possible that you may obtain 2 and 1, or you may obtain 2 and 2. So whenever we wrote down this x is going to be the sum of all of these cases, right? So either you can get the 2 as the sum, either you can get the 3 as the sum, this case or this case, right? Either you may get 4 as the sum. And what we have to do is we need to find the probability of all of these cases, and by putting them in a table, we are going to construct the probability mass function. So let's find, first of all, probability of getting 1 and 1. So please note that these 2 events are independent. Basically, you rotate the spinner. So here you've got a spinner again, one more time. So this is 1 and 2. You rotate it once. And no matter what is the result of the spinner in the first trial, the result of the second trial, like basically they are independent. Basically, the result of the first trial doesn't influence the result of the second trial at all. What does it mean? It means that if you get 1, it doesn't mean that the probability of getting 2 in the second trial is going to be changed. It is going to be the same as in the first trial. So this will help us to find the probability of getting 1 and 1. So in order to do this, we need to use the multiplication rule. So if you remember, the multiplication rule tells you that if you want that the events are going to be happen exactly in the order as you wish, just multiply their probabilities. So probability of getting 1 in the first trial and probability of getting 1 in the second trial are going to be multiplied. If I want that, I will get 1 and 1 in the 2 trials after rotating the spinner. So probability of getting 1 in the first trial is 1 over 4. Times probability of getting 1 in the second trial is also 1 over 4, so it's going to be 1 over 16. So now we need to find the probability of getting 1 in the first trial and 2 in the second trial. So actually it's going to be probability of getting 1 in the first trial and probability of getting in the 2 in the second trial. So this is going to be 1 over 4 times 3 over 4. It's going to be equal to the 3 over 16. And at the same time, probability of getting 2, so here's a mistake actually. So 2 and 1, sorry. So probability of getting 2 in the first trial and 1 in the second trial is going to be equal to the 3 over 4 times 1 over 4. It's going to be equal to the 3 over 16. So now we need to find the last case whenever we would like to get the probability of this case. Whenever we rotate the spinner twice and in both of the times we are going to get the 2's. So in order to find this probability, we need to find the probability of getting 2 in the first trial and multiply this to the probability of getting 2 in the second trial. It is basically multiplication of the 3 over 4 to the 3 over 4. It is going to be equal to the 9 over 16. So we actually found the probabilities for all the cases, right? So probability of getting sum S2, it means that sum as S2, it means that you need to get 1 in the first trial and 1 in the second trial. So probability is going to be equal to the 1 over 16. So probability of getting 3 as a sum means that either you are going to get this result or this result. So in both of the cases, the sum is equal to the 3. So that is why we have to sum these two cases, right? Or if you remember, this is the additional rule. So if one event happens or another event happens, we need to add the probabilities. The addition is going to be equal to the 6 over 16, right? And the probability of getting 4 as a sum, it means that you need to get 2 in the first trial and 2 in the second trial. That is going to be equal to the 9 over 16. So, So this is the table which basically tells us the values of our random variable, all possible values. They are 2, 3, and 4. And at the same time, they are probabilities. And this table is called the probability mass function. So hopefully you get now some insights about the mass function. And if you see to the sum of all the 3 probabilities, 1 plus 6 plus 9 is going to be 16. If you divide this to the 16, it's going to be 1. So the sum of the probabilities is equal to 1. So in our next lectures, we're going to discuss about the properties of the mass functions, and especially about the expected value and so-called variance of the probability mass functions. Thank you.